By order of the Royal Netherlands Army, Hollandse Signaalapparaten designed a test setup of a battlefield surveillance radar. This setup was tried out extensively in different sorts of terrain in the months of May and June of 1968. For these trials, the Army has drawn up a test program containing firm requirements as to detection range for different targets, detection probability, and accuracy. The test setup has fully met these requirements, and on the results of these tests, the Army will specify the final requirements. Unscreened targets, such as a moving truck and a group of 2 marching people, were detected at ranges of up to 23 and 17 kilometers respectively. The test setup consists of a modified L43 fire control radar. For economy reasons, the original magnetron and antenna, as well as the L43 vans were used. Consequently, the equipment is rather clumsy. The dimensions and weight of the final version of such a radar system will be reduced considerably, partly due to the application of micro-miniaturization techniques. The final conception will also depend on the expected tactical use in the Royal Netherlands Army. These film shots were taken when the radar was located on top of a hill about 50 meters above the surrounding country. The shots give an impression of the surroundings. The radar system operates in the X-band and consists of a coherent transmitter-receiver with phase detector and doppler filter circuits. Moving targets causing pulse-to-pulse phase differences produce a train of echo pulses in the receiver, the frequency of which is the same as the Doppler frequency. The Doppler frequency represents the radial target speed and is made audible by means of a loudspeaker and/or headphones. Apart from this, the target echo is displayed on the A-scope. Stationary targets produce an IF signal, the phase of which is constant with respect to a reference signal, so that no Doppler tone is produced. The antenna and a binocular sight, which is lined up with it, are together mounted on a separate vehicle. By means of a pair of hand grips, the combination of antenna and binocular sight can be aimed in azimuth and elevation. This makes it possible to search and follow targets visually at short ranges. People crossing the field are being followed with a binocular sight. The Doppler tone will be heard in the operator's vehicle. Vehicles constituting targets are driving to indicated stretches. The target vehicle is equipped with a transponder by which it can be distinguished from other vehicles and a radio link by means of which instructions can be given to the target from the test site. In the normal operational mode, the radar system scans a certain adjustable sector. Moving targets that are within a stepping range gate, followed by a Doppler filter, are indicated on a B-scope. The resulting Doppler effect is audible as long as the target is within the range gate. During the succeeding tests, the target is followed either visually with a binocular sight or manually from the operator's vehicle by keeping the Doppler echo on the A-scope within the range gate. Thus, the Doppler effect caused by the target will be heard continuously. A tank, a group of people, and a jeep on the sandy path that leads to the wood figure as moving targets. A turning reflector is set up at the edge of the wood. This reflector consists of wire netting of 1 by 1/2 meter. It's driven by a motor at a speed of about 1 rev per second. The group of people, the jeep, and the tank are emerging from the wood and are followed visually. A group of people on a path on the hill will now be followed. And now a jeep driving on a road in the vicinity will be followed. A group of people on a sandy path on the heath is followed by the radar.